We're sending highs from USA to Malaysia, and a special thanks to MIGO staff for allowing us to participate in this event.
We also give a special thanks to Winston-Salem State University for providing us with our results for this project. Thank you, Dr. Seaham, and let's begin with our presentation. My name is Hawa Sise.
And my name is Brilliant Newberry.
And this is our project,
Plankton's Battle with Global Warming.
Our project is figuring out whether the information of calcium carbonate fertilization in the ocean can be used to reduce global warming and heavy metal waste contamination. The aims of our study are to reduce the amount of carbon dioxide and also remove heavy metal waste contamination in the seas and oceans using calcium carbonate. Carbon dioxide is considered one of the main causes of global warming and the greenhouse gas effect, thus making carbon dioxide the most abundant gas amongst other greenhouse gases. Several researchers have proved to us that the shell of clams are made mainly of calcium carbonate. This calcium is then ionized when it enters calcium and CO ions. The calcium itself is one of the most needed elements by living organisms and is used mainly for growth. The calcium will help the phytoplankton grow and build their skeleton structure faster. Thus, adding a larger amount of calcium carbonate in the seas can stimulate the growth for marine organisms, such as fishes, crabs, and phytoplankton. And more specifically for our presentation, we'll be talking about how it affects phytoplankton. However, the more visible effect that we can observe is the growth of microorganisms instead of macroorganisms. The effect is visible for about after 1 week, and the phytoplankton will begin getting bigger and their numbers start increasing. A large amount of phytoplankton will then use up more carbon dioxide for photosynthesis. And since the numbers of phytoplankton in seas and oceans are very abundant, the amount of overall carbon dioxide in the seas and oceans will then be reduced. In our research, we take 2 liters of seawater. This seawater is then stored into 2 different 1 liter gallons. It is then equipped with the aerators to provide enough oxygen for the plankton so it can remain alive. The materials that we use for stimulating and testing the growth of phytoplankton include seawater, like I said before, an aerator, a pipette, a microscope, object glass, cover glass, and calcium carbonate, the pro-analysis version.
Okay. We started by dissolving 3 different masses of calcium carbonate. We did 0.1 gram, 1 gram, and 10 grams to represent different levels of it in actual seawater. And then we mixed it all together to ensure that it was fully incorporated. And every day we took samples from the top, middle, and bottom of the containers to see how it affected each growth. And here on our charts, you can see the different levels. More towards the top of our containers, there was more phytoplankton growth, considering that they used the sunlight for photosynthesis. For our heavy metals testing, we used 5 different metals. We used aluminum, mercury, copper, zinc, and lead. We did 3 different samples of heavy metal solutions with using 0.1 gram of calcium carbonate and EDTAs in some, and with just 0.1 gram of calcium carbonate and no EDTA in the others. And from our results, the calcium carbonate successfully bonded with the mercury, aluminum, and copper, but not with the zinc and lead. And while the calcium carbonate combined with several heavy metals, it was unable to bind with zinc and lead. And the clear colors in our results show that it is a similar result with the test from EDTA. And other than just stimulating the growth of phytoplankton in the water, calcium carbonate can help remove heavy metal waste in the water, saving a lot of marine organisms and making those and improving their life qualities. From From our results showed that the number and sizes of the phytoplankton were increasing as the days go by, and this can be explained by the accumulation of the calcium carbonate. And most of the calcium carbonate accumulated in the bottom, though the bottom and the phytoplankton still grew more towards the top. And from this, we concluded that the more calcium carbonate in the water is the more calcium carbonate in the water can be used up for phytoplankton for photosynthesis by the phytoplankton. And the calcium carbonate is able to stimulate the growth of the microorganisms, especially phytoplankton. And calcium carbonate has the ability to bind to mercury, aluminum, and copper, but not zinc or lead.
And in order to find those results for the heavy metal wastes, the materials that we used for that were an electric balance, spatula, a test tube, a magnetic stirrer, calcium carbonate, like I said before, but the pro-analysis version, EDTA, and an artificial liquid containing the heavy metal wastes. Like she said, mercury, aluminum, zinc, lead, and copper. Thank you for listening.
Thank you.